Alright guys, so the last two lessons we've been working on solving systems of equations by substitution and elimination. And some of you guys have really wanted to have an opportunity to know whether or not you were doing them right. So what I'm going to show you guys today is a quick way that you can use technology to help you check that systems of equations, your solutions to those systems. So we have solved systems by elimination and substitution so far. Technology helps us to check a solution to a system of equation by using a matrix, M-A-T-R-I-X. The plural of matrix is matrices, which is why you have it in the title up here. Okay, and a matrix or matrices is a rectangular arrangement of numbers. So we're going to have rows and columns. The dimensions are those rows and columns. The dimensions of a matrix, if it has m number of rows and n number of columns, are m by n. And that's exactly how we read it, m by n. So m would be a number of rows, n would be the number of columns. So what would our dimensions be for this matrix? Okay, if you think about it, rows, when we row sideways. We don't row up and down. So rows are going to go like this. Columns, C-O-L-U, I can't spell today, M-N-S, columns go up and down. Rows, when we row like you're rowing a boat, you row sideways. So we have, in this case, 2 rows, 1, 2, and we always do the number of rows first, and then we have 3 columns. So our dimensions for this matrix would be 2 by 3. Okay, and that's how we say it, 2 by 3. The numbers in the matrix, so all of these guys right here, there are 6 total in this matrix, are called elements. Okay, so the elements are what's in the matrix. So there are 6 elements for this matrix. What element is in the first row? First row, and third column. So our third column would be this column. So first row, third column would be 5. 5 would be the element that's in the first row and the third column. All right. Next, when we create a matrix from a system of equations, it's called an augmented matrix. A-U-G-M-E-N-T-E-D, augmented matrix. All right, here's a system of equations. This is what we've been working on. And this is its augmented matrix. How do you think we got from here to here? What do you notice? Well, hopefully you're able to see these numbers. Ooh, what is that number right there? Remember we said that's an understood 1, and in this case a negative 1. So hopefully you're able to recognize that those are coming from the coefficients, and then these numbers back here we call the constants. So they're coming from the coefficients and the constants. So what we're going to write down here, what do you notice? The numbers come from the coefficients and constants. All right, that's exactly where we get our numbers from in our augmented matrix. So down here, what matrix do you think can be used to represent the system of equations below? Write the augmented matrix, then state the dimensions. So you notice right here we have 6x plus y equals 7. So we're going to pull the numbers from each one of those terms. So we would do a 6, a 1, and then a 7. Here we have 4x plus 2y equals 8, so we would do 4, 2, and 8. Now, I have a little cloud over here that says before you write an augmented matrix, make sure the equations are in standard form. Okay. What I've given you so far, this guy up here is in standard form, and then these are also in standard form. Standard form is a, x, so your x term comes first, plus be y, so your y term comes next, and then equals c, and c is the constant, the one that does not have a variable. So a, b, and c are numbers, x and y are your variables. So these guys are in standard form. This guy right here is standard form. Okay, so you have to rearrange your equations and put them in standard form before you can do the matrix. That's really important. If you don't do that, then your matrix is going to be incorrect. It'll be in the wrong order all over the place. That's not going to work for us. All right, again, dimensions. Remember dimensions, row by column. So we have 2 rows, we have 3 columns. So 2 by 3. All right, so let's practice again. Write an augmented matrix for the system, then state the dimensions. So our first question, are these equations in standard form? And the answer is no. This one, these guys are just out of order. We have to have the x term come first. So this is a negative x. This negative x needs to move in front of the 2y. It is not changing sides, so it is not going to change signs. It is going to stay a negative x. So to rewrite this guy, it's going to be negative x, and then this is a positive 2y, so we're going to say plus 2y is equal to 5. Now this is in standard form. What about this guy down here? Is it in standard form? Again, look at where the equal sign is here. Your y and your x should both be on the left side of the equal sign. So this guy has got to change sides. To get him to go to the other side of the equal sign, we would have to subtract 4y on both sides. These guys cancel. 3x and 4y are not like terms, so we cannot add them together. We just put them side by side. So we're going to write the 3x minus the 4y, and then on the other side of the equation we have equals 1. Now these guys are in standard form. X, y equals number. X, y equals number. We're ready to go ahead and make our matrix with our coefficients and constants. We do want to keep them in the order they're in now. So this would be negative 1, 2, and 5. This would be 3, negative 4, and negative 1. The dimensions of the matrix rows would be 2, columns 3. So the dimensions here would be 2 by 3.